A whole other world of physics manifests to us. It's called quantum physics, where particles don't exist as discrete entities, they're also waves. And where might you find them? Well, you can't, because they might be here, they'll disappear and show up there. Nobody understands quantum physics.
What if I told you that everything you know about reality is just a fraction of what actually exists? That, at the smallest levels of existence, the rules of the universe as we know them simply break down. Welcome to quantum physics, the science that defies all logic and blows our minds in ways that no other field can. It's a realm where particles can be in two places at once, and where what happens to one particle can instantaneously affect another, even if they're light years apart. It's bizarre, it's confusing, and it's real. Quantum physics is not just a branch of science, it's a completely new way of understanding how the universe works. And today, we're diving into some of its weirdest and most fascinating concepts. From the strangeness of superposition to the mysterious phenomenon of entanglement, let's unravel the science that could literally change everything about the way we view the world. First up, let's talk about the idea of superposition. Imagine flipping a coin. In our everyday experience, the coin can either land on heads or tails. But in the quantum world, that coin could be heads, tails, and everything in between, all at the same time. Sounds crazy, right? But that's essentially what superposition is. Particles, like electrons, don't have one definite state until we observe them. Until we look, they exist in multiple states at once. This concept was famously illustrated in the thought experiment of Schrödinger's cat. The idea goes like this. You put a cat in a box, and in the box is a device that has a 50-50 chance of killing the cat. Until you open the box to check, the cat is both alive and dead at the same time, existing in a superposition of states. It's only when you look that the cat becomes either alive or dead. Now, Schrödinger's cat isn't real, but it perfectly captures how quantum particles behave.
Is that the cat is both dead and alive. It exists in the quantum superposition of deadness and aliveness.
Now, this idea of being in multiple states at once isn't just a theoretical concept. In fact, this kind of quantum weirdness is something that scientists have observed in the real world. One of the most famous experiments demonstrating superposition is the double-slit experiment. When particles like electrons are fired through two slits and then observed on a screen behind them, they don't just behave like tiny bits of matter. Instead, they create an interference pattern, as if they were waves. But here's the kicker. This interference pattern only shows up when we're not watching. The moment we try to observe which slit the particle goes through, it behaves like a regular particle, and the interference pattern disappears. It's as if the universe only decides what's real when we look at it.
If the trough from the wave from one slit met up with the peak of the wave from the other slit, they would destructively interfere and you wouldn't see any light.
But here's where things get even weirder. Superposition leads to something called quantum entanglement, a phenomenon that left even Einstein scratching his head. When two particles become entangled, they are linked in such a way that whatever happens to one particle will instantaneously affect the other, no matter how far apart they are. It's as if they share a secret connection that defies the laws of space and time. Einstein famously called this spooky action at a distance because it seemed to violate everything we know about the speed of light. If information is being transferred between two entangled particles faster than the speed of light, that would mean faster than light communication is possible, something that's supposed to be impossible according to the laws of physics. Yet experiments have shown that entanglement is real. It's one of the strangest, most mind-boggling phenomena in quantum mechanics, and it suggests that our universe is way more interconnected than we can imagine. Scientists have pushed the boundaries of quantum entanglement, with experiments involving particles separated by miles, yet they still seem to communicate instantly. This phenomenon challenges everything we know about the nature of space, time, and causality. Could this mean that the universe is much more connected than we previously thought? The implications are enormous. Some even speculate that entanglement could one day revolutionize communication technologies, like enabling quantum internet or even instantaneous teleportation of information. So what does all this mean? Superposition and entanglement aren't just abstract ideas for scientists to ponder in labs. These concepts have real-world applications, especially in the field of quantum computing. Unlike traditional computers, which use bits that are either a 0 or a 1, quantum computers use quantum bits, or qubits, which can be both 0 and 1 at the same time, thanks to superposition. This allows quantum computers to process massive amounts of data at once, making them exponentially more powerful than the most advanced supercomputers we have today.
Quantum computer. If you believe the hype, this nascent technology embodies the promise of the future and has the potential to revolutionize our lives with its turbocharged computation.
Quantum computers, in theory, could solve problems that would take classical computers millions of years to tackle in a matter of minutes. This would revolutionize everything from cryptography to artificial intelligence, transforming industries as diverse as finance, medicine, and logistics. Companies like Google and IBM are racing to build practical quantum computers, and while we're still in the early stages, the progress being made is nothing short of astonishing. But quantum physics isn't just about the technology of the future. It's also about answering some of the most fundamental questions about our existence. Take, for example, the multiverse theory. Some scientists believe that every time a quantum decision is made, every time a particle chooses between one state or another, it creates a new universe. In one universe, the particle goes left. In another, it goes right. This could mean that there are infinite parallel universes, each slightly different from the next. In one universe, you're watching this video. In another, you didn't even click on it. Isn't that wild to think about? It means that every choice, every moment, splits reality into an infinite number of alternate dimensions. And while we may never be able to prove the multiverse theory, it's yet another example of how quantum physics pushes the boundaries of what we think is possible. Quantum mechanics also challenges the very nature of reality itself. In the classical world, the one we live in, things have definite positions and properties. But in the quantum world, particles don't have fixed locations or definite speeds. Instead, they exist as probability waves, waves of possible outcomes. It's only when we observe these particles that they collapse into one specific state. This leads us to ask, does reality even exist if we're not looking at it? Physicists have debated this for decades. Some argue that quantum mechanics suggests the universe requires an observer to exist. Others think that the universe operates independently and our observations just collapse the wave function into something we can understand. Either way, quantum physics raises deep philosophical questions about what it means to exist. And then there's the question of time. In the quantum world, time behaves very differently than we're used to. Some physicists suggest that time might not even be fundamental. It could be an illusion that emerges from the underlying quantum nature of the universe. This idea would completely change our understanding of cause and effect, and it's still one of the biggest unsolved mysteries in physics. So, where does this leave us? Quantum physics may seem like an abstract and confusing field, but it's shaping the future of technology, deepening our understanding of the universe, and forcing us to question the very nature of reality. We've barely scratched the surface of what quantum mechanics can tell us, and the discoveries that lie ahead could be more mind-blowing than anything we can imagine right now. It's a reminder that no matter how much we think we know, there's always more to discover. The universe is stranger and more complex than we can comprehend, and quantum physics is the key to unlocking those mysteries. Thanks for watching this deep dive into quantum physics. If your mind is as blown as ours is, don't forget to like the video, share it with your friends, and subscribe for more fascinating explorations into science, technology, and the unknown. Let's keep pushing the boundaries of what we know, and don't forget to hit that notification bell so you never miss an upload. Who knows what incredible mysteries we'll uncover next?